morning, all of you. Myself, Professor Y. S&T College of Engineering Research Center, Yavula. Today we will discuss the swing equation, the subject of power system operation and control. In this equation, as we know that in synchronous generator, the speed of rotor axis and stator field axis is equal as to the synchronous speed. N is equal to 120 f upon P. During normal operating conditions, this simply during normal operating condition, this simply means that relative speed between rotor and stator axis and stator field axis under the synchronously rotating stator field axis with respect to time. This equation very helpful in analyzing the stability of connected machine. Machine here means generator. The angle is known as load angle or torque angle. The curve between rotor axis and synchronous rotating stator field axis. The value of load angle depends upon the loading of machine. The more is the load, the more will be the load angle suggested by the power. P is equal to F Vt sin del. Then synchronous rotating stator field axis and rotor axis curve shows that the value of load angle depends upon the loading of machine. The more is the load, the more will be the load angle is suggested by power equation. As we know that in synchronous generator, the speed of rotor axis and stator field axis equals synchronous speed during the normal operating condition. This simply means that the relative speed between rotor axis and stator field axis is 0. According to this speed, axis stator field and 0. Thus, constant angle is maintained between rotor field axis and stator field axis under normal operating conditions. During normal operating condition, is equal to 120 F upon P. P means pole, generator terminal voltage Vt, and synchronous impedance X. Also, during steady state operation of generator, the value of electromagnetic torque is equal to the shaft torque. Since electromagnetic torque and load torque act in opposite direction, there is no net torque on the rotor. This is the reason rotor rotates the constant angular velocity during steady state operator conditions. But when there is a sudden change in the loading of machine, if some load is added or removed, from the rotor shaft, the rotor will accelerate or with the respect to the synchronous rotating stator field. Suppose steam input to the generator is suddenly increased. Under this condition, the rotor will accelerate as the electromagnetic torque will remain almost constant during transient period, but shaft has been increased. Thus, the relative motion will set in the between the rotor and stator field axis. Since generator terminals are assumed to be connected to the grid, the stator field axis can be taken as a reference for study to relative motion. Due to the relative motion, the load angle vary with time and can be written as first and second equation. In the first equation, we see that during normal operating condition, first equation we see that del S is equal to omega RT plus del, where del S is the angle between the reference stator field axis and rotor axis at any time t. Time will be in t. Del load angle just before the rotor disturbance, where omega r is the relative angular speed between the rotor axis and stator field axis. Also, Ts minus T is equal to Ta, where Ta net accelerating torque. Since the synchronous machine rotates at constant angular speed, hence the above torque can be replaced power for analysis. Hence, T is replaced by electromagnetic power, shaft power. Thus, the rotor accelerating power can written as PS is equal to PS minus P is equal to PA. But as per mechanics, power is torque angular speed. Therefore, accelerating power, it is denoted PA. P is equal to TA omega. Since first we discussed about the torque, accelerating power Pa is equal to Ta omega since torque angular acceleration. Therefore, from Pa is equal to omega A, that M is equal to omega, but omega is angular momentum. Same is the called as angular momentum of generator rotor. Rotor shaft accelerating power it should be noted that there while applying machines for any mechanics for the any analysis of relative motion between rotor axis and stator axis, the unit of angular speed should be considered in mechanical radian per second. But since we can convert the mechanical radian per second into electrical radian per swing, but the angular position of rotor omega t describes that del is equal to omega rt plus del d omega s per dt is equal to omega r plus d del upon dt. Again differentiating right to time, d square del s per dt square is equal to d square del plus per dt square, but d square del s per dt square angular acceleration of the rotor. Hence from Pa is equal to ma is equal to md square d del per dt square, but Pa is equal to Ps minus P is equal to m d square del per dt square. The above equation is known as swing equation. Ps minus P is equal to capital M d square del per dt square. It is also known as swing equation. Thank you very much.